All right, Wiz, the latest agent is called Codex, but it's different than the Codex we just covered a couple weeks ago, Codex CLI. This one is Codex through ChatGPT, and it kind of is Codex in the cloud. Is that right?
Yeah, I mean it's basically just still the pattern of Codex that you might expect, which is that you're interacting with some kind of chat interface, and it is going to do some kind of autonomous development for you. But it's more meant as like a background process you're running in the web. We'll obviously dig into it a little bit more, but it's a more full experience than just the CLI tool.
Okay, so this is the autonomous software engineer that's coming for everybody's jobs too. This has already happened. The singularity, the gentle takeoff has begun. Like, are you worried after taking a close look at this about your job? Should folks out there be worried about theirs?
I mean, this is a difficult question to answer universally. I'm not worried about my job. I don't think that the AI is necessarily well equipped to replace. I do think that these tools are getting to the point that they're good enough that not using them is going to be a limiting factor in your or act as like an artificial ceiling, right? If you're anti leveraging these tools, I do think you'll be a little bit slowed down, even just to solve the blank page problem, as we'll talk about an example of.
Yeah, and the fun thing that we learned, we actually gave it the challenge we give all the humans that come into our boot camp called the AI Engineer Challenge. And we learned, like, it can do it, but maybe it doesn't bring the best vibes to the table, right?
Yeah, exactly. It's missing, OpenAI always talks about high taste testers and things like this. And certainly Codex in its current limited and, again, very like simply leveraged format, not high taste.
Not high taste, not high taste. So humans still have something to do, even on introductory kind of simple end-to-end applications, not just deep in production. So, okay, the future is bright still for humans. Love it. I'm looking forward to the demo today. You've been vibing it up this morning. We've got something good in store for everybody. And we'll try to end too, because, we did see that blog release from Sam Altman yesterday talking about the singularity. We've had some folks in our community kind of saying, this autonomous software engineer deploying these things at work. I'm not sure exactly how to feel about this. This is sort of an interesting, bigger discussion that once we cover the concepts and code, we'll get into at the end. I'm excited for this one today. You ready to rock?
Always.
Let's go ahead and get into it. Welcome, everybody, to A-SWE, the autonomous software engineer. This is Codex. Not the last Codex, not the Codex before. It's the Codex of now. And I'm going to tell you a little bit about how Codex came to be what it is today, what they are looking at Codex being tomorrow. And then we'll talk about what the latest version can do on its own, as well as in tandem with something like a Codex CLI, and where all this is headed. We'll talk about some of the features, some of the use cases that people are leveraging this for today, even within OpenAI. And of course, we'll see if it can complete the challenge. Spoiler alert, it can, but maybe not on the first try, as we'll see. So this is a really, really powerful tool, a really important thing to go ahead and start getting your hands on. And hopefully this session today will help you do exactly that. If you have questions along the way, please go ahead and throw them directly into the YouTube live chat, especially as we're discussing. We might go ahead and pop them up on the screen, or if you're on LinkedIn or any other viewing platform, just throw them directly into the comments. And with that, let's go ahead and get into it. Codex, the autonomous software engineer. So today, what we really want to do is we want to understand what we mean by this autonomous software engineer, this A-SWE, and how you should leverage them as a human. We want to compare Codex to other tooling options in the industry. We've sort of outlined this before, and this is sort of more for the end of today. this kind of thinking about the different levels of agent autonomy, thinking about where Codex fits in compared to, let's say, a Devin, a Manus. Is it less or more autonomous? What exactly is the state of the art today as we sit here on June 11th? And what are the best practices for using this thing? How is it trained? What do we know about it? And how can we use everything we know under the hood to inform the way we choose and select use cases for Codex in the future? We wanted to really actually test out, could this thing do the AI Engineer Challenge? And it's pretty dope that it could. So, you know, if you guys are looking to get into the next cohort, you can definitely cheat on the challenge using AI to build the AI. It's getting pretty meta out here. First, I want to go into a little bit of this sort of rebirth of Codex that continues to happen over and over, and tell the story of that before we get into some of the details of the tool, the demo, and the future. Okay. Bringing it back, Codex. Code execution is the whole idea behind this thing. And, you know, I was listening to a podcast yesterday that one of the main product guys and one of the main engineers from the Codex team were talking to Sequoia Capital. And, you know, the big idea is that this name was, quote, too apt to abandon. The code execution name was sort of born of the original Codex model that was a code completion, more of a GitHub Copilot style. This actually underlied the initial GitHub Copilot. This was August 2021 when OpenAI was doing this in partnership with GitHub. 2 years later, fully deprecated, the Codex models were no longer things that you could pick up off the shelf and use. Fast forward a little bit to more years, and they released, as we covered a month or so ago, month and a half ago, the Codex CLI tool. Now, importantly, the CLI tool is used within your CLI, which is on your local machine. That's the way you interface with the operating system. It's the command line interface. And so it very much is local on your machine. This lightweight coding agent that runs in your terminal is going to have access to your stuff fundamentally. And, you know, we sort of covered that Codex command line agent. And the idea is that we can get ChatGPT level reasoning plus the power to do a bunch of cool stuff like run code, manipulate files, and iterate. All of this stuff we'll see is kind of part and parcel of Codex also in the cloud that we're kind of talking about today. Codex proper, I guess, Codex Senior, Codex A-SWE, the one that was released just a few weeks ago, is the software engineering agent in the cloud that, and this is the important part, can work on many tasks in parallel. And it's powered by Codex 1, a specific model that we'll talk about in just a moment, further ambiguating the language around this. But if we can keep it straight, it all actually is pretty straightforward, despite some of the naming schemes, if we look under the hood. And as of a week ago, they also said, well, Codex is now available, ChatGPT Plus users. We're also enabling users to provide Codex with internet access. So we cannot just put it kind of in a container in the cloud, give it access to a terminal and a machine, but we can also give it now access to the internet. So more and more, these things are getting more and more access. As a result, you know, presumably they're going to become more and more performant and more things. So if we listen to what the actual team who built this is saying, they're saying Codex is our brand for agentic coding. So while it might not make sense today necessarily, it will make sense eventually, and it will be super clear to everybody, such as the nature of startup. We have this agent, and it should be mostly able to work on its own computer. That's kind of what it's doing today. But it should also be able to eventually meet you in any tools you use wherever you work. The terminal, your IDE, any sort of issue management tool you're using. So the idea is that Codex is going to be kind of an umbrella term that's going to include all of these components. It's going to be, just Codex. And it could be in ChatGPT, it could be in your CLI, it could be in your IDE, it could be in your issue management tool, it could be wherever, but it's your coding agent helping you out. Now, the lines between the specific ways it does this, they are important, but I think it is important to understand the reason why these rollouts are happening. This is a great line from Alexander. One of my favorite things about working at OpenAI is how willing we are to cut scope and just ship. That's really, we love to hear that, build, ship, share. They're getting after it, even though they're an unbelievably large startup and they're shipping when things aren't quite ready. It really is cool to see. So in the end, the name, it might not make a ton of sense today if we look at the whole suite of things, but as we move forward, we can kind of start to imagine a future where Codex is a little bit more ubiquitous across the different ways we might engage with building software. So let's talk about the agent. Let's talk about the Codex proper agent. This is an autonomous software engineering agent that can work on many tasks in parallel. That's really what we want you taking away right now. If you're not doing many tasks in parallel, you're not really understanding how to best leverage this tool. It's an autonomous software engineering agent. We like to define agent at AI Makerspace as a system that can leverage reasoning to make dynamic decisions in an application flow. If we think about a coding agent, which is what this is, it's an autonomous software engineering or coding agent. A coding agent is a system that can leverage reasoning to make dynamic decisions to produce working and functional code. Okay, so this coding agent is going to use reasoning to make decisions about code to write, and then it's going to do even more stuff as it starts to try to go beyond just writing the code. Codex is a coding agent that has its own container and its own terminal in the cloud. It's sort of sandboxed up there. The idea is you put in a task, a specific well-defined task, and it comes back with a PR, just like a junior developer. So it comes back with something that's going to allow you to complete this task. And again, we're moving to talk about the one that's in ChatGPT, the one that's in the cloud. The CLI tool is a separate tool today. We expect an integration of those in the future. So just pausing for a moment here, Wiz, I want to invite you up to sort of have a quick discussion about this. So is the point then moving forward with something like Codex that we can work locally in our terminal and we can work in the cloud and it's sort of seamless in between? And is that different than a computer use agent today? We kind of have these terminologies we need to pick apart.
So yes, right? The idea is, this combined idea is that it's kind of sits, many different computer use, right? So it can use your computer, it can use your terminal, it can use a sandboxed container in the cloud, right? I can do all kinds of different things, but the idea is that it's their vision for this product is that it can just exist wherever you exist, and it has access to all the tools that you have access to, or certainly the tools that you provide it access to. Is the more apt way to put that. But it is literally distinct from just like a computer use tool. It isn't meant to click your mouse around and browse the web on your behalf. It's more so focused on these CLI tools and CLI interactions. But again, that's Codex right now, June 11th, 2025.
That's right.
who knows what's true in a month or 6.
Yeah. So, but this specific one we're talking about today, the Codex through ChatGPT, the one that's in the cloud, that one is sort of sandboxed and relatively safe, so to speak, which I think is part of maybe what they heard from their users when they released kind of the computer use style agent, that it's like, the security issues here are starting to worry me. But so, then they're coming out with this. It's okay, guys. It's in the container. It's in the cloud. It can only be there. It's looking at your stuff, but it's taking it to its little place and looking at it. It's not messing with anything down here on the local prem. It's okay. Is that kind of a good way to think about this new one?
I mean, yeah. Like I would say, the idea is that it is more sandboxed when it's in this cloud environment. It has a little container. The container has limited access to the internet that you have to specify, right? And I think at the end of the day, is this, totally safe? We can quibble about it. Is it certainly safer? Yes, right? Because it's not your machine, and because it's not your machine, that's better.
Yeah. Okay. And then also, right, they just added this internet access thing. And famously, like, everybody's worried about GPT-2. Like, oh my God, we can't give these things access to the internet circa 2019. And so it does, once we give it access to the internet, there is additional security issues there. There are additional, it's not perfectly safe, but they are sort of envisioning this world where it all comes together and, everything's safe and secure, but you also have infinite kind of vibe possibility space to code as you wish. Something like that. And
you don't want to limit the vibe space, that's for sure.
Definitely not. Yeah. The vibe space might be infinite, and maybe that's where we need to live as humans in the end. But for today, it's not really a computer use agent because we're not giving it access to our point and click mouse. But it's also not really the CLI agent, although there might be an integration in the future. So just to clarify this for everybody before moving forward.
Yeah.
Okay, cool. Thanks, Wiz. Let's keep it moving. Let's talk about how we actually use this cloud-based tool. Using ChatGPT Codex, you put in a task, you get the PR. That's kind of the big idea. You basically submit this description, and then it's going to open up a little container with terminal, a little virtual machine in the cloud. This is going to allow you to sort of just set it and forget it. And you might give it a bunch of different, again, tasks. You might spin up a bunch of different ones, but really trying to get it to do a lot of stuff while it's running in parallel, while you're kind of doing other things. This is the real, it could run for tens of minutes. This is the real sort of, I'm working because my code is running is sort of a past paradigm. This is like part of me working is my codes and my agents are always running for me. And so this is sort of the new paradigm that we want to be thinking about. So while it's running, it's going to be opening up PRs. It's going to be writing tests and executing tests. It's going to be returning stuff basically for the human to come in and be like, oh, okay, I see it did pretty well on this, did pretty well on that. Should we actually merge this in? Should we actually make this change? Are there updates we need to make? Do we need to keep iterating on this? Basically treat it like a junior developer is kind of the right way to think about using ChatGPT Codex today, in short. And, when we think about the use cases, when the team that built this was talking about kind of the sweet spot of use cases, they really kept going back to bugs, finding and fixing bugs. And then, adding small features, doing refactors, but really the bug hunting, even, and the team told a story in that particular podcast where they were like, well, it took, 4 tries right before we were launching Codex to fix this animation bug issue. And only on the 4th try, right before we were going to launch, we sort of merged this in and launched. And so it is really kind of shines in this space of bug fixing and bug identification more than anything is what has come across based on my research of this and based on what the team seems to be saying even as of this week. Let's dig into the models a little bit here, because this I think is really important to understand and to sort of connect to Codex. So yeah, it's a cloud-based software engineering agent that can work on many tasks in parallel. It's powered by Codex 1. So what's Codex 1? Well, Codex 1 is actually a model that's been taken off the shelf at OpenAI and then fine-tuned, a classic pattern. The model they're taking off the shelf, though, is already a super powerful reasoning model. It's O3. It's actually my personal favorite model, as everybody that works today on Makerspace knows. I really love these reasoning models. O3 Pro tends to chew on things quite a bit longer here, but O3 has this nice balance of sort of quality and timeliness, and it's then fine-tuned. And so what they kind of fine-tuned this thing to be more like was more like a professional software engineer. So, you know, better pull request titles and descriptions, better code style, the kind of thing you'll see in production, better test writing. And so the analogy here that is apt is that O3 is like the competitive programmer who really has never had a job, kind of the college student who's maybe crushing some hackathons, but has never really worked in production. Whereas Codex 1, they really tried to add those first few years on the job through this process of reinforcement fine-tuning. And this is something that basically OpenAI is built into their API now, but it allows you to sort of take a reasoning model off the shelf and define some feedback signal that you want to optimize towards. The nuts and bolts of this require you to essentially articulate a grader. And the grader is going to grade outputs. Based on the grading, you're going to then update model weights, and you're going to sort of keep moving, hopefully be more optimized towards the specific tasks you want. And so this can allow you to sort of get better at all sorts of different things, be more safe, be more a specific style, have better, you know, outputs in a specific domain. Obviously, this is a very specific use case where we want it to be more like a professional programmer. More like a professional programmer has specific things that we're looking at. And when we do reinforcement fine-tuning, we want to be super duper specific. We want to implement a grader that can have a number, right, that we can optimize towards. Classic reward modeling, classic optimization scheme. We need to have prompts that are well-defined and have structured, well-defined outputs. And then we do fine-tuning, and then we hopefully, you know, it works pretty well. Now, there are some things to keep in mind that this made this a good candidate space for them to do this, you know, that the tasks were actually, you know, fine-tuning on. And this is important because it sort of takes the A-SWE thing down a few levels from magic to like, oh, okay, they're basically giving it very, very specific tasks that a programmer would do, very unambiguous tasks, and kind of making sure that those can be done well and to spec. The grader needs to be something that, you know, you're able to assess across the right number of, you know, features and dimensions, what really matters to you. And so the grader is sort of the meta idea. But again, here it's like you're grading, you imagine you're the senior dev grading the junior dev. How well did you do? And so you kind of have the programmer saying, okay, that was really good. That was not so good. And importantly, like the O3 reasoning model had already had some success on being able to do this. So there was a delta between like sort of maximum and minimum accuracy and ability to do this already that they could kind of close the gap on by doing this reinforcement fine-tuning. And they also really needed to make sure that anything that they were putting in during the fine-tuning wasn't something that they could, that you could see sort of reward hacking come about, where you're just guessing to get the treat, to get the reward, and then you're saying, okay, hey, good job, model. When really it didn't do such a good job. So all of this is important if you go and you try to do some reinforcement fine-tuning on your own. And they did really take the time and care to take O3 to Codex 1 to make sure that this was done right. If you look into this kind of thing, you can start to understand exactly what Codex 1 can do, what it can't do, and when you might be using it in such a way that it really wasn't designed to be used in. The environments they created, because a big hurdle here was getting the right prompt and the right output. So they needed to find like realistic production grade repos that would allow them to do this type of reinforcement fine-tuning. And so they built these sort of learning environments up in the cloud, containerized with access to the terminal, so that you basically could never, the agent would never be able to say to you, hey, it works on my machine. That was sort of the big goal. Agent can't say works on my machine, and it's better than O3. Okay, these are the big takeaways. And then also, they want to teach to be a little bit more patient. It could take up to 30 minutes. It's not going to maybe go for an hour, but 30 minutes is a long time to be chewing on tokens. Occasionally, it will return and admit like, yo, that was too much, but it's kind of, again, a step towards this leveraging the test time compute paradigm more and more and more towards this idea that those with the most test time compute might be able to think through problems the most and might be able to come up with the best solutions. So this is definitely a step in that direction. Now at OpenAI, what they said is they said, well, the people who really get this, the people who pick up Codex, they should be kicking off 10 plus tasks per day, letting Codex run in parallel with different tasks, and then reviewing and merging results. This sort of, as we got shouted out in the chat here, was like the abundance mindset idea. This was the big idea that they had, is like, it's like you really, really want to come into this like feeling like you're going to use Codex to just generate a whole bunch of stuff that you can then review with more of a keen human eye. And you can pick, you can separate the wheat from the chaff that gets created. And it's almost a little bit reminiscent of some of the early ChatGPT sort of outputs and models that we might remember from a couple of years ago. And, another thing that people do is they'll ask Codex the plan. They'll ask it for the plan first. Then they'll just take the plan and then they'll iterate on the plan before they actually put it in to Codex and tell it to execute the whole thing. They've seen some PR throughput go up. That's obviously a great metric if you're an engineering leader, for you to look at your team. Are the PR throughputs going up after I made the investment in autonomous software engineers? Well, if they're not, people probably aren't using them. And then, there's some sort of helpful tips that people are taking away from using Codex already. We want to help the agent be good at their job, just like the junior dev. We want to allow it to have structures and setups in our code that are easy for it to navigate, that are allowed to pattern match across the different file structures and repos that we're going to give it access to. And we also want, importantly, to start thinking about shifting our time from writing to reviewing. So Wiz, I want to bring you up for this just to sort of put a fine point on this for everybody. All that's great, but like, when should I use Codex if A, I'm a software engineer, and if B, I'm not really a software engineer? Because it's starting to sound like maybe I shouldn't even use this if I'm not a software engineer.
Here's the thing. I do think you can use this tool to great effect if you are not a software engineer. I think we can define like a gradient of okay to great at leveraging this tool, right? And I think the further you move into your software engineering journey, the further toward great you're going to wind up being. But there's some additional burden, which is to do with like, well, okay, that is true, but also you have to be pretty good at understanding how to prompt these things, et cetera, et cetera. And so if you come from that background, you're also going to be moved further towards great on this gradient, right? And I think so you can be pretty good at using Codex to produce code, right, without being a software engineer. Certainly, you're going to start from a better foundation if you have the background, just because Codex is not yet like writing beautiful, incredible code off the hop, right? It's not going to whip up a whole app for you that looks exactly how you imagine it, even if you labor over the prompt for hours. And so, you're kind of, the skill floor is lowered by being a software engineer to produce, great code. But certainly you can get started with this, and certainly you can use this as a tool to help you understand how software development might work. And if you want to do things like figure out, well, how do I contribute to a open source repository, Codex can help you understand, and tinker with some changes and see, how to get started, where to get started, how to help fix bugs, things like this. And so it's a great tool for beginners, but it's a better tool if you know the code.
Like, because that's what it's supposed to be. It's supposed to be your code helper.
It's cooler. It's like you can drive a souped up car. Anyone could drive a souped up car that knows how to drive, right? But like, in order to push it to its limits, in order to get the most out of the souped up car, if you're a professional driver, you're gonna be able to push it faster, right? You're gonna know exactly how to take the corners. It's the same thing with Codex, right? Like, you can still drive it around. You can have fun. You can enjoy it. You can build cool stuff, and maybe that sparks a joy and interest that you didn't have before. But if you know what it's doing and what it's trying to do, you're going to be so much more effective at getting it to do stuff you want.
Yeah. Okay, so but let's say I just, I'm not a professional, but I like the idea of renting a supercar, right?
Yeah.
Because the immaculate vibes I'll get throughout the day. Like, is there a way that if I've done some vibe coding with Cursor today, that I should think about leveraging an autonomous software engineer to help me take my vibe coding to the next level? Is that a thing right now? Or maybe just like, try it out?
Yeah. I mean, I would approach it like you approach using Cursor. If you're already into these tools, these AIDs that help you vibe code and stuff like this, I would approach it in the same way, right? Make sure your agents.md is fully fleshed out. Really spend a lot of time crafting the prompt. Apply those skills. You're going to find that it does mostly what you would expect it to do, which is probably going to be relatively similar to the experience you have with other tools like, Cursor. However, don't expect to produce production-ready, thousands of user applications with a few prompts, right? Like, that's not.
People really, are they really curating their prompts, and are they really like dialing in their agents.md file during vibe coding? I think maybe it's kind of the classic thing: garbage in, garbage out, right? And then if you don't have the right prerequisites, you don't give it the right access to the right stuff.
We like to make this distinction, right, between like vibe coding and AI assisted development.
That's right.
AI assisted development is always going to allow you to produce better end results than vibe coding. If you just want to let the vibes flow, stick with Cursor, stick with Windsurf. Codex requires a bit more effort, and therefore, there's a slight hint of friction, which is that it creates PRs, which means that you must open PRs and merge PRs, and that's one step away from just running the code, and I think that's a a good way to think about it.
Okay, cool. Yeah. All right. Well, Mustache Leaks, let us know if you take to the next level with the A-SWE. See if this level of Codex can do it for you. Okay, Wiz, let's go ahead and get into the build today. We'll see you right back in just a moment. Let's introduce to everybody how we're going to take Codex and we're going to do the AI Engineer Challenge. This is something that we encourage everybody who wants to get started building, shipping, and sharing to do. It's a requirement for our boot camp, but it's also just a great way to get that aha moment, to get that wow moment, to get a public URL link that you can share your first AI application with anybody that you know, your boss, your family, your mom, your dad, your sister, your brother. You can text it to them, you can send it to them, you can email it to them. It's a really, really great way to get started. And recently we revamped this and we did some different app hosting with Vercel. We vibe coded the front end. We just do a simple orchestration with the OpenAI Python SDK. And it requires us to set up our AI assisted development environment. As we just mentioned, AI assisted development, not vibe coding, is the future. And so the challenge really is to set up the IDE and then deploy your first application. And as we heard, Codex kind of sets up its own IDE in the cloud. So that's pretty nice. Let's see if it can deploy its first app using the LLM app stack we recommend. And that has become pretty industry standard, the one that leverages in-context learning. So we don't have to worry about all of this. We just have to worry about a few pieces. And those few pieces have specific tools that we're interested in. All of this is outlined in our AI Engineer Challenge repo that we can give Codex access to. So Wiz was playing this with a bit this morning, and it turns out it can kind of do it. Maybe not as good as each of you out there, but hey, not so bad for an AI. Wiz, show us how Codex can actually complete the AI Engineer Challenge as an AI engineer. LOL.
Yes. Okay. So this is we'll go through the whole thing. Okay, so basically what we have is we have at AI Makerspace, as Greg was outlining, the AI Engineer Challenge. And it's not very difficult. It is meant to make sure your developer environment set up, make sure you're understanding what kinds of things your tools can do. And so like at the end of the day, what it is it's forking and cloning the repository. It's setting up for some vibe coding. It's vibe coding a front end, and then it's deploying with Vercel. So there's not a lot of steps, right? And effectively, the front end folder is empty, right? We just have a README, but the API exists and is expecting certain inputs. Okay, so what are we going to do? Well, we're going to go to Codex. First, we're going to fork the repository, and you'll see, spoiler alert, I've already done it. We didn't want to make you guys just watch it churn through PRs. But the idea is that we have all of the work that it did to get to this point. So instead of just, showing you exactly what it did, which I think would probably be like not as fun to look at, we're just going to talk about, how we set up the environment and then how we leverage the tool to continue. And we'll work through some of the PRs. But you'll also see that like this is completely and totally like a multi-step process, right? So it didn't one-shot the challenge right away. The prompt that I used, as you'll see, was not like so comprehensive that I would have expected it to, but it's also true that it didn't. Okay, so what do we got to do to use Codex? Number one, we have some settings. These settings include custom instructions. This is like a system prompt, right? You can identify the kind of branch format you want, since it is always going to open PRs for you. I'll zoom in one more tick here. And then, of course, we have, do you want to see the unified diffs or split diffs? This is basically when we look at the code, do we want to see them side by side with the differences visible, or do we just want to see it in a single file? This is unified, similar to what you might experience if you know Cursor Windsurf. Data controls, obviously we can connect this thing to GitHub. The actual settings in GitHub allow you to configure per environment and per repository, accesses. So you don't have to include all repositories. You can include only a few. And then this is our classic, are we training? There is some docs. We're not going to worry about those, but they're okay. The idea of setting up an environment is as follows. You're going to select your organization, and then you're going to select your actual, repository you want to work with. In this case, we already have this environment set up, so we'll take a look at it in a second. The idea is pretty straightforward, right? We just have to provide a description and then do some stuff with our environment controls. So let's look at the one that we used for that AI engineering challenge. And you can see, right, that we're using this universal image. The agent has no access to the internet, which is going to be important. There are no environment variables or secrets. We have this one setup script, which is that it's going to run UV sync once it gets into the repository, and that's it. So you can see here, right, we could do things like give it access to different images. We could have it choose different versions of common prerequisites, right? We can also add environment variables or secrets. So like our OpenAI API key, if we were working with the closed API. We can also give it internet access, right? It's going to tell you right away, this is maybe a risky thing to do, big orange text, right? So it's no illusions. But you can see that we have the ability to allow specific domains, right? So by default, you can allow common dependencies. You can also allow everything, which is very risky. But you can specify or allow list specific domains if you want to as well, right? So we're going to look at this in a second, but you can, like, say I wanted it to have access to the original challenge repo, I can actually just provide that access. So it can't reach out to the internet generally, right? But it can reach out to a specific part of the internet, which reduces some risk a little bit. We can also limit what kind of HTTP methods that it's available to use. Again, this is all security things. And then you can see that we can actually, boot up the container that it's going to use when it's doing this coding for us, right? And this is important because if we wanted to verify what kinds of dependencies are available or what kinds of internet access it has, we can do this before we start having it do tasks. So you see, it's just going to boot up, and we're not going to wait for it to boot up. But the idea is that it's going to boot up, it's going to run some commands, and this is our little sandbox, right? And that's the big benefit of this tool is that we get this little sandbox, and now all of a sudden, we can see that we're in this environment. We can run commands like we would in a normal terminal, and that's pretty cool, right? All right, so once we've got it set up, we're going to go ahead and go back to our chat area, and we're going to make sure that we're choosing which environment we want to use. So in this case, I'm going to want to use the engineering challenge. We can click use this, and now I know that I'm in this environment. And let's look at some of the tasks. First of all, we have complete AI engineering challenge, the absolute most generic instruction in the world. Hopefully, most of the context is in the README. Please complete the AI engineering challenge. Your task is to look through the repo, determine what the challenge is, determine how to complete the challenge, and then provide a link to the burst cell deployment that you set up. You might be wondering, why is this burst cell instead of Vercel? Well, if you come back to our handy window, you'll notice that there's a little dictate button. You don't even have to type to Codex. You can just talk to it. Okay, so we get back some initial, results. And you can see this thing's just slamming through absolute great web element there. You can't select the taskbar, or the scroll bar, but you can see what it does. You can also see it runs tests in the little container, right? You can see burst cell deployment could not be created, so no deployment link is available. So I meant for cell deployment. It continues on, and again, this is this idea of like the unified diff, right? We see that the removals are in red in the same file at the line as the additions. So this is just if you want to see them side by side, to have that capability. But you'll notice, like, that's all we do it, right? Boom, boom. It just goes through, it produces code, and it produces a non-functional website that looks bad. So we have to ask it to do more things, right? We can also, though, just chat to it. So we don't have to write code. I'd like to know a bit more about the engineering challenge. She looked through the repo and described to me what this challenge is. Also, what difficulty would you write this challenge? And we get the summary. The idea is that it reads through all of the content available in the repository. It gives us a summary, and then it tells us the overall difficulty is beginner, perhaps leaning to lower intermediate if you're very new to the space. But this is the idea, right? It creates PRs, and then you merge the PRs. So let's go to the repo that I was working in, which is going to be here. And if we go to our pull requests and we go to close, you'll notice these are all of the PRs that it produced, right? It gives us these decent kind of, PR summaries. It gives us the chat it was associated with, what kinds of tests it ran, and then we could just merge, the PRs as we desire. That's it. So basically, once this was done, all I had to do was git clone and then git or npm install Vercel and then Vercel, and then we got this, which is our challenge website. And this is what the completed challenge looks like. And we can see, if we enter our API key, which you should be, weary to do on screen, but we have, Codex knows that you got to use little dots. Say things like, hey, what are you up to? And we can ask our question, and we're going to get the response from our system. They don't have anything that they're up to because they're an AI assistant, but this is the idea. You'll notice that this looks terrible, but it does work, right? Codex doesn't promise that things are going to look amazing. But let's say we wanted to make it look less bad. We can just do that. Please convert this to a more modern UI with a matrix style theme, right? We can just hit the code button, and then it's going to open this new thread. It's going to start working on this, and then that's it. It will ship code, right? Again, this is how you would get started with this tool. It would look a little bit different if you're working in a big production workspace, but that's the idea. With that, we'll pass you guys back to Dr. Greg so we can have a little bit of a chat. And before I do that, though, I'm going to ask you to, subscribe and ring the bell notification. We're here every Wednesday. Next week, we'll be here live, which is very cool, from TMLS. And with that, we'll go back to Greg. Okay.
All right. Yeah, Wiz. So I want to go ahead and take a look. This is actually from the Codex release blog. If you scroll down to the very bottom here, I'll just kind of pull this down quickly. You can actually see that they've shared, which is really cool, the system message or the developer message for this. And they mention, for example, the Codex 1 system message encourages Codex to run all tests mentioned in the agents.md file. But if you're short on time, you can ask Codex to skip. And so I think it's just, it's sort of, again, tripling down. I'll zoom in just a little bit here so we can kind of read it just a little bit better. But the instructions here is user will provide a task. Task will involve working with Git repos, at the highest level here, right? So it's wait for all terminal commands to be completed. So it very much is a developer tool. And it's one that, I encourage everybody to look through this. If completing the user's tasks requires writing or modifying files, do this, or don't do this, do this. If this fails, try it again. And then more on agents.md.spec. I just want to kind of show this because it really is, it's not that long, first of all. And second of all, it really sort of shows that this is a developer tool. If you're interested in using Codex, understand who it was designed for. And if that wasn't you, just, use it with a grain of salt here. And
I think, one of the interesting things about, so we have many of this agents.md or cursor rules, or, everyone's got their own Claude.md, right? Everyone's got this idea of, we want to have some way to inject per project specification, per project, rules that should be globally applied to the project. And the reason we want this is because, you know, the agent itself shouldn't have that like personality, or shouldn't have that, you know, specific desire to write like with React or write with SvelteKit, right? Like it should have it should be a blank slate, which is why we see a kind of lightweight system prompt that we can expand on with our agents.md. And so one thing that I want to point out to people, or make sure people are aware of, is like that agents.md can and should be pretty beefy, right? If you look at you know, the kind of meme anatomy of a you know, OX prompt, like you should provide a ton of context. These models are context hungry, and they're getting context hungrier. And so, you know, don't feel like you shouldn't you know, have a very comprehensive agents.md. And the other thing you can do, right, is have boilerplate agents.mds that you can then append per project specifications to, if you have some, you know, globally desired kind of, you know, context you want to add. So this is, it's still just prompting, right? Like at the end of the day, the model is fancier. It's got access to more tools, but the only thing it does is it reads context and then it outputs tokens, right? Like that's still what the model's doing. And so the quality of you know, prompt you provide is of utmost utility.
Yeah. So like the vibes on that, you know, input that you used during your demo of the AI Engineer Challenge, its response was like, meh, yeah, there were no vibes, because the vibes have to be flavored by us. We as the humans, we got to bring the vibes, you know, because we don't, unless it's trained on our vibes, you know, it's trained to do the specific thing it's trained to do. Okay, let's go ahead and get into this last piece of it, Wiz. We'll see you back in just a moment. So the way we want to end today is we want to think about the future a little bit of coding agents. Now, we've covered the idea of coding agency, and we've sort of outlined a way to think about it across 9 different levels. And we covered the CLI coding agent in terms of Codex CLI recently. And we've talked about the IDE coding agent with sort of the cursor and AI engineer, you know, guide to cursor, the AI engineer challenge recently as well. This sort of web coding agent, you know, we just saw Codex is given access to the web. This sort of AI engineer that's autonomous, this sort of autonomous software engineer. This level 6 is kind of where we're at when we're talking about Codex. And we always want to kind of think, how far away are we from the actual work being done? How far away are we from the scoping, from the planning, from the reasoning, from the coding? And as we saw today, we're using a reasoning model. It's doing the coding. Maybe a best practice is to work with it to develop the plan and to develop the scope before we actually set it off on the task. But the reasoning and the coding are even the planning in some sense is being done more and more by the AI. So what are we left with? We're left with, you know, as Marco says, like scoping the product to make sure that it's pretty good. And, you know, there's iterations of each of these, because maybe we use ChatGPT to scope the product in the first place. You know, and as we move through the levels here, and we've covered these in a previous event, we can kind of think about this level 6 as being quite interesting. This is the Manus, the Devon, the Codex level, the autonomous AI engineer, the autonomous software engineer level. We're not yet at the level of entire teams, although we see this picture start to be painted by the Codex team. We're not at the level of a fully autonomous AI organization yet, but hey, who knows what the future holds. This is from the team talking about what they expect in the near term and in the long term. And in the near term, when they think about more agent types, we've seen operator and deep research. You imagine you're going to have a tester agent. You're going to have, like, you can honestly break up the junior developer role into individual roles and maybe reassemble them back again later. But the more and more we have agents, the more and more we're moving towards this team. And the more and more we're moving towards this vision of like the universal ChatGPT, all hail ChatGPT, with every tool and every agent that you'll need kind of thing. And it's really interesting to think about how the majority of code may actually be written not by human hands, but more on the CPU of the agents. And, you know, it's part and parcel of the week. Saltman himself released the gentle singularity. So Wiz, we are past the event horizon, it seems. And, you know, I just want to get two final thoughts from you as we're kind of ending this event on such an interesting week. You know, first of all, is Devin or Manus more advanced or less advanced than Codex? Quick question.
Less.
Okay. So if I'm going to get started and I want to pick one of these things, which one am I starting with?
I would probably actually start with Codex. I think it's a little bit closer to the ground. Manus and Devin have very specific use patterns that you kind of have to grow into, and so I would suggest just starting with Codex. Feels a little bit more familiar, and if you really like that, but you wish you could be a little bit further back, even still, then Devin and Manus are going to be what suits you well.
And we finished a recent cohort, and one of the students mentioned, hey, I just deployed an A-SWE at work, but I'm not exactly sure how to feel about this. You know, what is the right way to think about deploying these kinds of systems at work? You know, like, how are you thinking about this from from Wiz perspective, more of a practical, how do we get more done, be more productive with these systems? There is sort of the ethical piece of, should I do it for good and not evil? And I don't want to really take people's jobs and all of that. Let's leave that for another day. But are we sort of thinking, as we think about deploying these at work, what should be the things that we're looking for as, you know, really killer use cases that can deliver some ROI today, not in a year?
Yeah, I mean, the way that I like to use these tools, so this is specifically like, Codex or either of the codexes, to be honest with you, is my usage pattern with AI that I think is good. I mean, I'm very biased, obviously, is to use them as verifiers, right? So did I miss anything obvious? Did I miss anything silly that I just wasn't thinking about, right? Is there some obvious way that I can change things or modify things? I think at the end of the day, I would continue to want to use them that way, right? So for something like Codex, it's great if you come up with do some work, and then you want to know, did this work get executed well? Do a bunch of automated reviews, have like a set of prompts that you like to run tests with, kind of like AI powered tests. This is the pattern that I think is useful for these tools. Using it in the flow of development, I'm still leaning more towards the local tools. Obviously, that's where you're doing a lot of development. But for things like, CI/CD, but like plus, I think that's where Codex and the other kind of autonomous SWEs shine. Doing the work people really hate doing.
Tedious stuff that should be automated. Oh my God, I can't believe it.
But you need to do, or else your application crashes, right?
Tedium. So really, like, when we think about Rajat here, it's like, no, we're not recommending that beginners become dependent on these tools, but leverage them to effect if you're doing a bunch of tedious work over and over.
It's like the idea of, I think that the way that I would explain this, I know we're very close to time, but the way I would explain this, the way I think about it is, we always used to talk about boilerplate, okay, in software development. Boilerplate. Oh my God, boilerplate. Oh my God, boilerplate. Right? If name equals Dunder main, right? Like, this is, oh my goodness, right? I think the boilerplate has grown in scope tremendously with the advent of AI assisted development, but we still want to be writing the actual code, the real code, the working code, right? I don't want to write like connectors or interfaces as much. AI is writing that quote unquote boilerplate for me, right? I don't want to listen. testing is a very important but tedious thing to do. I would love if AI automates some way that testing, quote unquote, boilerplate, right? And I think we're allowed to focus on the fun, difficult part of the problem a lot more, and AI is effectively leveraged to smush boilerplate. It's just our view of boilerplate is expanding as capabilities of these tools expand, and eventually boilerplate might be most of, if not all of, the code, and we're sitting in the pilot seat, just directing the models where to go and the agents what to do and how to craft things. So that's how I'd think about it. But don't become dependent on it to write the fun, interesting problem code. That is what humans are good at. It's the fun puzzle solving part of the job, right? Of software development. And I think offloading that is just it'll make you feel good, today.
That's right. That's
on
right.
2 weeks.
Yeah. Okay. So then, in the end, we have Codex. The future of Codex is the universal ChatGPT. Codex CLI allows you to work locally. Codex through ChatGPT works in the cloud. Codex 1 took O3 and fine-tuned it. Understanding the fine-tuning really gives you insight into what you should use this for, and maybe treat it like not just a junior developer, but a team of parallel junior developers, so to get the very, very most out of this. I'd like to just have one question. I know Mark has kind of been going back and forth in the chat here, answered just kind of this idea of like, should we be using this to help a new person get more experience faster? Like, if you're using this as a junior dev, should you give it to your junior devs?
Yes.
This is the whole, like, the white collar entry level is bottoming out. Like, it's like you can't sort of get the junior dev role unless you can sort of be a junior dev plus.
Yeah. I mean, like, every developer workflow could benefit from something junior to them. And so you should give developers at all levels access to tools that act as force multipliers. I think if you're hiring people, straight out of college, they're already going to be so used to using these tools, right? Like, limiting access to them, I think, is just going to wind up being a productivity dent. So that's why the hesitation on the yes.
Okay. All right. Well, thank you, Wiz, for the AI Engineer Challenge and the sharing of the knowledge today. We look forward to seeing you back next week live from TMLS. All right. I'll see you in Toronto soon, buddy. And thanks, everybody, for joining us today. We are AI Makerspace, and we are on a mission to create the world's leading community for people who want to build, ship, and share. That's people. That's real humans like you using AI tools. And building, shipping, and sharing is at the core of everything we do. We will be live next week if you'd like to join us from Toronto. And we're going to be at the Toronto Machine Learning Summit. We will have that announced in our newsletter this week. But if you join live, we'll tell you what you're missing at the Toronto Machine Learning Summit. We're not getting the preview up here, but we'll tell you what we're taking away from hearing from the folks that are deploying these systems in production live from the conference. If you're looking for a place to build, ship, and share with a community, you can join us on Discord. Every week we kick off the week with some accountability. And this is a place where you can just start with the AI Engineer Challenge through Codex if you'd like today. Join the Discord. And if you're looking to accelerate your LLM application development, consider joining us for cohort 7 of the AI Engineering Bootcamp. This should be a banger of a bootcamp. This is going to be the biggest cohort that we've ever had. And it's going to be one that serves North America as well as Europe. We've got a ton of new agent stuff, including Codex stuff involved in this one. So if you're really looking to triple down on engineering, to actually write the code, to become an AI engineer, this might be for you. Kicks off 2 weeks from yesterday, June 24th. You can learn on your own. This is an easy way. We've sort of developed a roadmap to help you walk through our YouTube content in an easier way. And if you have any questions about it, feel free to hit me up personally to help get you on the path to building, shipping, and sharing. So thanks, everybody, for joining us this week. We look forward to seeing you on Discord, seeing you next week on YouTube. And until then, keep building, shipping, and sharing, and we'll do the same. See you soon, everybody.